are the different types of activation functions with respect to the model of the neuron. There are many different types of activation functions, but we will look at two types of activation functions, that is a threshold function and then the sigmoid function. That is, in case of threshold function, the input is given by the V actually. What it tells us, if the V is greater than equal to 0, output 1, whatever. That is, if V is 2, then the output is 1 only. If V is 1, then output is also 1. If it is greater than or equal to 0, it is 1 actually. But if Vk takes the value less than 0, it squeezes to 0. Whatever, whether it is -1, -1.5, -1, anything, it squeezes to 0 actually. Okay. It is what it is trying to do. It is trying to, whatever the input it is getting, output it is showing in the range of 0 to 1. That's all. Always the output will be in the range of 0 to 1. Next, we will the model of the neuron which uses this threshold activation function is called McCulloch-Pitts model actually. That is a Pitts model we will call actually. Because here you can look at this BK, now it is treated as separate, not as an input here actually. Therefore, J will go from 1 to M here and this thing. And this input, when it is provided, if it is greater than 0, it is 1. If it is less than 0, 1. For example, if you get a question or explain the Pitts model, then you can tell it uses the activation function, that is a threshold function, and then BK is treated by us is treated as a separate input, separate, not along with the input, and then here the expression will go from 1 to M. Next, we'll look at sigmoid function. Most of the times in many of the NN models, neural network models, deep learning, most of the models we use this particular sigmoid function. The sigmoid function, the graph is a S-shaped actually, is by far the most common form of the activation function used in the construction of the neural networks. Most of the times we use this particular activation function. It is defined as a strictly increasing function that exhibits a graceful balance between the linear and the non-linear behavior actually. An example of the sigmoid activation function is a logistic function which is given here. It is 1 divided by 1 plus exponent of minus a multiplied by v. V is this particular input and a is the constant, or we are going to call that a slope parameter. Now, depending on the variation of the a actually, the curve will be always S-shaped, but either the curve will come down or go up actually. But here the case is shown where if we keep increasing the a actually, the curve will go slightly above actually. But what we are trying to do, always the output, in the sense, it is not squeezing completely to 0 and 1. That is, if the output is say, uh, sorry, if the input is -1, it is, if this is my curve, it is outputting something like this here actually. Okay. It will be in the range of, it will not be 0 and 1, but it will be in the range of 0 to 1 values actually, because it keeps going like this actually. Threshold activation function, in the sense, it gives only two outputs, 0 or 1, always. Only two outputs will be there. But sigmoid activation function is not like that. It gives any value in between 0 to 1 actually. Whenever we want this output, then we are going to use the sigmoid activation function. Sometimes instead of 0 or 1 or 0 to 1, we also need the output in the range of -1 to +1. At that time, we can use this hyperbolic tangent function actually. If we use the tan h for this input, if b input is 0, it will be the 0. If V is greater than 0, it will produce 1. If V is less than 0, it will produce minus 1 actually. This is that is, we looked at three activation functions. That is, one is a threshold activation function, and then the other is the sigmoid activation function, and the other is the tanh activation function. That is, threshold activation function gives output either 0 or 1, but this gives in the range of 0 to 1 actually. And this also tanh will give in the range of minus 1 to plus 1. This you should be aware of.